solving systems in 3 variables. There are 2 methods they use. The book calls them elimination and substitution, but in reality you're using both of those methods when you're solving these problems. Now, we're going to start with this one, and I like to start by numbering the equations. So I'll just number them 1, 2, 3. Okay? Because we have to use all 3 of them while we're solving the problems. And what we're going to do is you look at the problems in general. You just kind of scan them, see if there's anything real easy. And I don't have any where the coefficients are additive inverses of each other. That would be ideal. But I do have a couple here where we can do one simple step to eliminate them. So if we take equation 1 and equation 3, okay, I can multiply equation 1 by -1, and then we'll have additive inverses. So let's do that. We're going to multiply everything in equation 1 by -1. So we're taking equation 1, making it -5x plus 2y plus -z equals -11. Now we're going to take equation 3 because we've got a -2y, and that will eliminate that one. So here's equation 3, 6x minus 2y minus 2z equals 16. Now, we are going to combine these. Just add them like we would when we are solving a system in 2 variables. We're going to have -5x and 6x is just x. These 2 go away. They're eliminated. -z and -2z is -3z equals 5. Okay. We're going to give this an equation. This is equation number 4. Now, we need to do something like this again so that we have another equation in 2 variables. So this time I'm going to take equation number 2 and multiply equation number 2 by 2. So I'm going to take equation number 2 and multiply it by 2. And we're going to have 2, let's see, it's going to be 4x plus 2y plus 6z equals 0. And take equation number 3 again. 6x minus 2y minus 2z equals 16. And add those 2. And we're eliminating the y's. That's what we want to do again. Okay, so those will go away. We've got 10x plus 4z equals 16. Okay, we're going to call this one equation number 5. Now we're going to deal with equations 4 and 5. We have 2 equations, 2 variables. We can solve that system fairly quickly. If we take this equation number 4 and multiply it by -10, then we can eliminate the x's. So I'm going to multiply that by -10. So equation 4 times -10 is -10x minus 30z equals -50. Grab equation 5. 10x plus 4z equals 16. Add. Okay, they're going to be eliminated. Did I do something wrong here? Yep, I did. Okay, that should be positive because it's -10 times -3. Add them. We've got these eliminated. This is 34. Z equals -34. Divide by 34. Z equals -1. Okay, one variable solved for. Now, if z equals -1, I can plug it in here to get x. So x minus 3 times -1 equals 5. So x plus 3 equals 5. Subtract 3, x equals 2. Now, we're not done yet. We still have to find y. To find y, go back up to one of your original problems. Does not matter which one. I'm going to choose equation number 2. and plug in. We've got x is 2, so 2x plus y plus 3z equals 0. Okay. This is 4 plus y plus negative 3 equals 0. 1 plus y equals 0, so y equals negative 1. Now, when we write the solution to this, it is an ordered triple. We've got x, y, and z. The solution is 2, negative 1, negative 1. X, y, z. Alright, here is another problem. It's similar to the other one. The difference here is that one of our equations only has 2 variables. We like that because that's going to make our lives a little bit simpler. So we're going to start with this first equation. Okay, again, number the equations just because it helps to distinguish between the 3 because there's so many of them, it's easy to get confused. We're going to take equation number 1, 3y equals negative 9x, and we're going to solve for y. Okay? When we solve for y, we're going to divide by 3. Y equals negative 3x. Okay? And I slipped up and used the wrong variable. These are z's. You know me, I do that sometimes. So 3y equals negative 9z. Solve for y, we've got negative 3z. The math was correct, I just used the wrong variable. Shame on me. Now what we're going to do is we're going to take equations 2 and 3. We're going to plug in 3z for y into both of those equations. Okay, so starting with equation number 2, plug in 3z. We've got 4x plus 2 times negative 3z minus 2z equals 0. Simplify, okay, 4x minus 6z minus 2z equals 0. Keep going, combine your like terms. 4x minus 8z equals 0. Okay, now we have 4x minus 8z equals 0. I see that 4 is a factor of 8. So I can easily solve for x. Let's solve for x on this, and you'll see why in a couple of minutes. So when we add 8z to both sides, we've got 4x equals 8z. Divide by 4, and we've got x equals 2z. Okay. Now we're going to go back and we're going to grab equation number 3 and plug in. We could actually plug in for x and for z, but let's just start here with y and plug in for y, and then we'll go down. Then we'll go on. Okay, grabbing the third equation, negative 3x minus negative 3z plus 4z equals negative 2. Okay, simplify. This is equation number 3. Plus minus and negative becomes plus the positive. Negative 3x 3z plus 4z is 7z equals negative 2. Okay. Now, we need to solve for, here we've got x equals 2z, here we've got negative 3x plus 7z equals negative 2. Okay, if we plug in 2z for x right here, we can solve for z very quickly. Okay, so I'm going to take this x, which is 2z, and replace it right there. So negative 3 times 2z plus 7z equals negative 2. Negative 6z plus 7z equals negative 2. When we add these, we've got z equals negative 2. One variable solved for. Now, we need to solve for another variable. take your z, plug it in here, and we've got x. Okay? So, taking the z, we're going to substitute it down here. We're going to have x equals 2 times negative 2. So, x equals negative 4. Oh, look, z is negative 2. If I plug in z over here, I've got y. Okay, so I'm taking that negative 2 and I'm going to plug it in over here for y. Y equals negative 3 times negative 2. Y equals 6. Okay, now our solution is an ordered triple. We're going to take x is negative 4. Y is 6. And z is negative 2. That is our solution.